finishing up the lesson 9 notes. We didn't get a whole lot. It felt like we didn't get a whole lot done last time. We talked about radicals and square root principles, square roots, properties of radicals, simplifying radical expressions, and the very last thing we did was rationalize the denominator. Here's where we are, ready to talk about rational exponents. Sometimes radicals are just difficult to work with, and we already have so many exponent rules, and we're already so good at simplifying exponential expressions or expressions with exponents that if there was a way to write radical expressions as expressions with exponents, then we could use all of the exponent rules we already have. So that's what the first part of today is about. And then the second part is solving some more quadratic equations. All right. Definition of a rational exponent. Let me write that right here. Rational exponents. And the word rational in math means a fraction. So we're talking about exponents that are fractions. For any integer, any whole number greater than 2, if a is a real number and m and n are integers containing no common factors, I'm going to let you just read that and soak it in a minute. Here's what's important. What a to the 1 over n mean? When you're seeing a fraction, let me back up 1 second. I tried to hypnotize y'all the first day of class, I think. And I said, whenever you see a negative exponent, from now on, there's an R word that's going to pop in your head. You remember what that R word is when you see a negative exponent? Take the reciprocal of the base, and that makes the exponent positive. So here's our second hypnosis section. Whenever you see an exponent that's a fraction, there's also an R word that I want to pop in your head, and that's root. When you see a rational exponent, you think the word root. And the denominator of that exponent tells you what root you're taking. So a to the 1 over n, if you write that with a radical, it's the nth root of a. Whatever the denominator is, that's the root you're taking. So if I wrote 81 to the 1/2 with a radical, what root would it be? Second root. And what do we call second root? We don't usually say second root. We say square root. 81 to the 1/2 just means the square root of 81. It's 9. If when you see a rational exponent, the word root pops in your head, then it's easy to work with. It's easy to change that to an expression with a radical and then evaluate it. Now, this second definition has the same denominator, and it still means the nth root, but that numerator's not 1, it's something else. So you take the nth root of a, just like before, and then you raise that to the nth power. You raise it to the power indicated by the numerator. Or you can also raise a to the nth power and then take the nth root of that. These two things are equivalent. And I'm going to show you that. I can show you that right here. Let me just add an example. If I say, if I say 16 to the 3/2, what would that be with a radical? What root are we taking? The denominator's 2, so it'd be square root, the square root of 16 I could either take the square root of 16 and then cube it. What would that be? Square root of 16 is 4, and 4 cubed is 4 times 4 times 4. 64. That's one way I could evaluate that problem. Another way I could evaluate that problem is, say, 16 to the 3 halves would be cube the 16 and then take the square root. The way I first did it, I took the square root and then cubed. I'm saying now you can also cube and then take the square root. But the question is, which one of these things can you do without a calculator? Probably this first one. I can't do 16 cubed in my head. I would get the same answer, but this is easier. So this is the way we usually apply that rule. We take the nth root first and then apply the exponent indicated by the numerator. So the second example, 125 to the 2/3. What root is being indicated there? Always the denominator. That's the cube root of 125. And after we take the cube root of 125, we have to square it. So cube root of 125 is 5. 5 times 5 is 25 times 1 more 5 is 125. And then square it, and you get 25. 125 to the 2/3 is 25. And the cool thing about this is, I'll finish that sentence in just a second. Yeah, let me leave that sentence for just a second. We've already had an exponent rule that said when I have factors raised to a power, I can raise each factor to the power. Or on this one, I can just change that. What root is indicated by that exponent? The denominator. So it's 4th root of 16x to the 20th, y to the 8th. Can you think of what you multiply times itself 4 times to get 16?
2.
It has to be small. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So 2 is the 4th root of 16. Now this one, think about it. What would you have to multiply times itself 4 times to get x to the 20th? Absolutely. And what do you multiply times itself 4 times to get y to the 8th? Yeah. Y squared times y squared times y squared times y squared, you'd add those exponents and you'd get 8. So really, on the previous page, when we were simplifying the D and the E parts on the previous page, we said to simplify a cube root, all of the exponents must be multiples of 3. To simplify a 4th root, the exponents need to be multiples of 4. And you just take 1/4 of the exponents, or divide each of the exponents by 4. All right, one more. How would I write that with a radical? What root is being indicated? That's cube root of -64. And whatever that is, I need to square it. I need to apply that exponent in the numerator. So is cube root of -64 a real number? Can you think of something you multiply 3 times that would give you -64? Yeah, you can multiply a negative 3 times and get a negative. You can't multiply a negative an even number of times and get a negative. But this is a real number, -4, and then I need to square it. But what's wrong with the way that I just wrote that? I made a very common mistake. Tell me what you think, Justin. And how would I show that it's included? I need parentheses to say that negative is part of the base. The cube root of negative 64 is negative 4. I need to square negative 4. And without the parentheses, I wouldn't be squaring negative 4. So that's positive 16. All right. The next three problems just say rewrite with a radical. So you look and see what root is being taken. In the A part, cube root of 6x. No, it's already with a radical. It says write it with an exponent. Cube root of 6x would be 6x to what power? What power means cube root? No. 1/3. 1/3. The denominator tells you what root you're taking. So if you want cube root, then the exponent's 1/3. We're going just the opposite of what we did above that. We changed the exponent to a radical. Now we're changing the radical back to an exponent. B part is 12c in parentheses cubed and then 5th root of that. If I just wanted to write that as 12c to a single exponent, what would that single exponent be? Absolutely. The denominator is the index of the radical. The denominator would be 5. And then since that's raised to the 3rd power, the numerator is 3. And one more, 6th root of the fraction 2x over y raised to the 5th power. If I wanted to write that as just a fraction 2x over y to a power, what would the exponent be?
5, 6.
Beautiful. 6 is the denominator because that's the index of the radical. 5's the numerator because that's the power that the 2x over y is raised to. All right, now back to that sentence I started, the beautiful thing about this, and realized I wasn't ready for that sentence yet. The beautiful thing about this is if we can change radical expressions to expressions with exponents, we already know exponent rules. Let's just review the exponent rules. When you multiply two expressions with the same base, what do you do with their exponents? You add them. When you divide two expressions with the same base, what do you do with the exponents? James, what do you say? Yeah, bottom exponent from the top exponent. So a to the m minus n. This just means as long as the base is not 0. The base can't be 0 or you're dividing by 0, and we know we can't divide by 0. This third property says when you raise one power to another power, what do you do with the exponents? You multiply a to the m times n. The fourth property says if you have a product to a factor, or excuse me, to an exponent, you can raise each factor to the exponent. But you have to be careful. Some people say the same thing about when you have a sum to a power. This is a product. These are multiplied and raised to a power. This is added and raised to a power. You cannot just raise each term to the power. For example, if you have a plus b squared, remember one of the most common wrong answers for that is just a squared plus b squared. Why is it not just a squared plus b squared? How do you evaluate this? Something like that was on the first test. Because you're writing it down twice and foiling it out, and you're going to get a middle term. A plus B times A plus B. When you foil that out and combine like terms, you get that, not just A squared plus B squared. So the moral to this story is if you have a product to a power, you can raise each factor to the power, but when you have a sum to a power, you can't just distribute the exponent. Fifth property, when you have a fraction to an exponent, you can just raise the numerator to the exponent and the denominator to the exponent. And then what did you tell me about negative exponent? What R word pops in your head? Taking the reciprocal of the base, that would be 1 over A, makes the exponent positive. Now it's to the positive n. Or if you use this fraction property, this one, and you raise 1 to the n and A to the n, what's 1 to any power? So you could write that as 1 over A to the n. These two things are the same because 1 to the anything is still just 1. So let's see if we can use those same 6 rules for exponents to simplify these. Okay. Use the law of exponents to simplify rational exponents. 81 to the negative 2/3. Now, let me deal with that negative first. What are words hovering in my head when I see the negative exponent? Reciprocal. And what R word is in my head when I see a fractional exponent? Root. So I'm going to take the reciprocal of the base, 1 over 81, and then that's going to be to the positive 2/3. I could put the 1 over 81 in parentheses, but I know 1 to the 2/3 is still 1. Now notice there was nothing that ever causes me to flip an exponent. I'm not flipping that exponent, I'm taking the reciprocal of the base. And then 81 to the 2/3 indicates what root? Cube root of 81. And after I take the cube root of 81, what am I going to have to do to it? Square it. This is a little bit harder than I thought it was because 81 is not a perfect cube. I'm not going to give you one on the test or the homework that you can't take the cube root of. I mean, I could do this. It would take a few more minutes. It would be easier if I did this problem, if I changed this to the exponent negative 3/2. Let's just change the problem to make it easier to work and so that it won't be harder than what I would put on the test. That's a much easier problem. Much easier because 81 is a perfect square. I can take the square root of 81 as 9 and then cube it. The way it was, I was about to have to rationalize a denominator, and that's another 5-minute talk that we don't have 5 minutes for. Any questions on this? Make sure you understand, we changed the original problem. We didn't just split a fraction here. All right, the B part. When I have something, a product to a power, I can raise each factor to the power. Right now, what's the exponent of this one, or excuse me, this 4 and this x inside parentheses?
1.
They're both to the first power. And when I raise a power to a power, what do I do with the exponents?
1.
So I multiply the 1/2 times this one, and the 1/2 times this one, and the 1/2 times the 2/3. That would be 4 to the 1/2, x to the 1/2, y to the, what's 2/3 times 1/2? Without your calculator real fast. The 2's cancel and just leave you 1/3. Or 1/2 of 2/3 is 1/3. And then I still have that x to the -3y. What does 4 to the 1/2 mean? Square root of 4, and square root of 4 is 2. When I multiply these two x's, what can I do with their exponents? You add them, and yay if you can do that without having to punch it on your calculator. If you have to punch 1/2 minus 3, you can, but it's 1/2 minus 6/2 is -5/2. If you don't know how to get that on your calculator, hang around a minute after class and I'll help you. And then when I multiply the y's, I add their exponents. The second one is 1, and 1/3 plus 1 is 4/3. And then finally, the directions on the test say write with positive exponents only. Do you see how I could write that with only positive exponents? Just bring that factor with a negative exponent down to the denominator. Now notice I didn't right off the bat change this something to the 1/2. I didn't change it to the square root of the whole thing. I wanted to use my rules for exponents. And if I change the whole thing to a radical, I can't use my rules for exponents. So the only time I change exponents to radicals is when I'm evaluating a numeric expression, when I'm trying to figure out what 81 to the 3/2 is. Either on paper or in my head, I have to think that means square root. But I'm not going to change this to square root because I'm wanting to use my rules for exponents. And that means I have to keep exponents. All right, one more big scary one. The order of operations says if you have a stuff in parentheses raised to a power, simplify the stuff in parentheses first. You don't have to, but it makes life easier. All right, so I'm going to simplify what's inside parentheses first. 25 divided by 1 is still 25. What do I do with these two exponents when I'm dividing the x's? And yay if you can do it in your head. If you can't do it on the calculator, circle it in your notes and come see me after class. I don't know how to do this in my head or on paper or on my calculator. But it would be 12/3 minus 1/3 is 11/3. I'm going to make a little note up here. That is 4 minus 1/3. And then when I divide my y's, that's 1/2 minus 1 is -1/2. And then I still have that 1/2 outside the parentheses. These factors raised to the 1/2 means raise each factor to the 1/2, or think of that 25 as having its own exponent of 1. Multiply the 1/2 outside the parentheses by each exponent inside the parentheses. 25 to the 1 times 1/2 is 1/2. X to the 11/3 times 1/2 is 11/6. And y to the negative 1/2 times 1/2 is negative 1/4. What's 25 to the 1/2? What does it mean? Square root of 25, which is 5. And I'm going to go ahead and write the x to the 11/6 in the numerator because it has a positive exponent. Y to the 1/4 in the denominator because it had a negative exponent. Now, feels like we got more done in 25 minutes today than we got done in 80 minutes yesterday. Let me just remind you that I chose these examples very purposefully. I looked at the answer or the problems that I put in the homework, and I tried to give you examples like those. So if you see a problem like this in your homework and you just go, man, I have no idea what I'm supposed to do there, first place you need to turn is your notes, because there's a good chance there's an example like that in your notes. Now, if you have a problem like this, but just has different numbers in it on the homework, ladies, do you need to ask me something? I never flip an exponent. I take the reciprocal of the base. That may be a good note to put up here, and then I'm going to finish that sentence I was in the middle of. Let's see, how do I want to write that? I know where. Where was that rule? Right here. Right here's a good place for it. Here's the rule that says when you have a negative exponent, you take the reciprocal of the base. So I'm going to put caution right here. Take the reciprocal of the base, not the exponent. That probably deserves 2 exclamation points and a highlighter. So, Miss Barbara, that's the answer to the question, why don't I flip the 1/4? Because it's the exponent, not the base. Okay, now, I got sidetracked because I can't, when I'm talking, you're missing good stuff. What was I gonna say here? I don't remember what sentence I had started. Well, if it comes back to me later, I'll tell you. Yeah, let's keep going. All right. Lesson 9, the title of it was Roots, Rational Expressions, and Quadratic Equation. Well, Monday, we simplified roots. Today, we've talked about how rational exponents mean the same things as roots or can be written as roots. Now we're back to solving quadratic equations. And solving quadratic equations was the video that y'all had to watch last Wednesday because I was out. We only, number one, we said a quadratic equation, how do you recognize it? Got a bunch of equations mixed together. How do you pick out the quadratic ones? Are you saying it? Nope. That's actually exponent. What about the exponent?
Its highest is 2.
That's it. The highest exponent of any variable is 2. Lord, I think I've asked y'all that like 5 days in a row now. Quadratic equations are second degree equations. If the highest exponent is 2, you're looking at a quadratic equation. And in lesson 8, we only talked about one way to solve quadratic equations. We spent most of the class or most of the video reviewing factoring, and then we said, hey, you can use factoring to solve equations. If you have an equation, a quadratic equation, second degree equation, and you get it set equal to 0, then you can use the principle of zero products, which says if two things multiply together to give you 0, then what has to be true? B 0. If A times B is 0, then either A is 0 or B is 0. So at the end of lesson 8, we took little baby equations like, I'm just going to make up one super fast, x squared plus 5x plus 6 equals 0. If that will factor, and it will, it factors into x plus 2 times x plus 3. If it will factor, then we can say, if these two factors multiplied together to give me 0, then either the x plus 2 has to be 0 or the x plus 3 has to be 0. We've broken a quadratic equation down into 2 linear equations. We solve those 2 linear equations and we get the 2 solutions, -2 and -3. So that's the way we solved quadratic equations in lesson 8, but we know that not all quadratic expressions will factor. We've seen some in that video. We saw some that were, what was that word for an expression that would not factor? Oh, yes, prime. If this was prime, I couldn't factor it. I'd have to use a different method. So our other 2 methods, other than factoring, are the square root method and the good old quadratic formula. Let's talk about the square root method first, and then we'll get to the quadratic formula. The square root method says, if I can get an equation in the form something squared equals a constant, I can just take the square root of both sides. But I need to be careful when I take the square root of both sides. If I have x squared equals 100, right there, what do I get when I take the square root of both sides? What can you square and get 100? 10, but is 10 the only number you can square and get 100? There's something else. What is it? -10. That goes back to in lesson 9 when we said any positive number has 2 square roots. The principal square root is the positive one. We could write it as this. The negative square root is the second square root. So whenever you take the square root of both sides of an equation, third hypnosis, two hypnoses in one day. So if you feel a little dizzy after class, that's fine. From now on, when you take the square root of both sides of an equation, when your brain thinks, take the square root of both sides, bells and whistles are going to go off in your head. Bells and whistles that only you can hear. To remind you, you get the positive or negative square root. That's how you get the positive or negative 10, not just 10. I'm gonna circle it and put a big old arrow to it and say, get. When you take the square root of both sides, don't forget your plus or minus. Now, because 100 was a perfect square, we just squint and solved that one. We just looked at it and knew the answer. How could I get this in the form of this? What could I do to make this equation in this form?
Add 7 to both sides.
Just add 7. And then it'll look just like x squared equals 100, but only 7's not a perfect square. What can I square to get 7? Square root of 7. Only I just took the square root of both sides of an equation, so I should have thought what? Bells and whistles to remind me what? Don't forget the positive and negative square root of 7. How about 20 of those on the test? Would that be good? 20 times?
I mean, we could just be a over repetitive.
Folks would just be happy for the A. This one is a tiny bit different. It's not just x squared, it's x minus 4 squared. But I can still get it in this form. I can get something squared on one side and the constant on the other just by adding 9 to both sides. And when I take the square root of both sides, what bells and whistles go off? Don't forget the plus or minus. If x minus 4 squared equals 9, then x minus 4 has to equal either positive 3 or negative 3. You can write it plus or minus 3. And I'm not through solving that equation because I don't have the x by itself. But what's the only thing I'd have to do to get the x by itself? Add 4 to both sides. I'm going to write it x equals 4 plus or minus 3. You could write plus or minus 3 plus 4. That would be the same thing, but it would just look kind of odd. And don't leave that as your answer either, because you can simplify it further. 4 plus 3 is 7, and 4 minus 3 is 1. So those are your two answers. And what's the fabulous thing about taking a test on solving equations? Can you think of anything that's fabulous about solving equations? They're always checkable. Always checkable. If you put a 7 in place of this x, you have 7 minus 4 is 3. 3 squared is 9. Sure enough, 9 minus 9 is 0. If you let x be 1, then inside parentheses you'd have negative 3. But negative 3 squared is also 9, and 9 minus 9 is 0. So you can check these. All right. So if you give me a bunch of quadratic equations mixed together, or if you just give me a bunch of equations mixed together, all kinds of equations mixed together, I'm going to recognize the quadratic ones because what? How am I going to recognize the quadratic ones? Highest exponent is 2. So if I pick out all the quadratic ones, first I will try to solve them by factoring. If I have an expression that will factor, then that's the easiest method. But if I can't factor, I'm going to see if I can get in this form something squared on one side and a constant on the other, because that's pretty easy too. But then there's the good old if all else fails method. If all else fails, the quadratic formula will always work. And if we weren't in a hurry, weren't always in a hurry, I would show you where the quadratic formula comes from. But since we're always in a hurry, I'm just gonna say, you can sing it to the tune of Pop Goes the Weasel. And that's what I rocked my babies to sleep with every night. X is equal to negative b plus or minus the b squared. Plus or minus the square root of b squared minus 4ac. Oh, yeah, toss them up in the air. It's hard to get them to sleep that way. All over to a. It's only sometime I'm singing to you. This quadratic formula, these coefficients are extracted from this equation in standard form. So just like before you factor, you have to get the equation in standard form. Before you use the quadratic equation or quadratic formula, you have to get the equation in standard form. Once you have that in standard form, A is your coefficient of X, A is your coefficient of X squared, B is your coefficient of X, and C is your constant. You're just plugging numbers into this formula and then simplifying it. And that's why we had to talk about simplifying radical expressions. We had to know how to simplify something like that. So we have two of these examples. The first one, it's already in standard form. Now, if you didn't tell me how I had to solve this equation, first thing I'd do is see if it would factor, see if that left-hand side would factor. Remember, this would be the hard kind of trinomial. I'd multiply 1 times 2 and say, are there factors of 2 that have a sum of 4? No, so it's not going to factor. And I can't just get it x squared on one side and a constant on the other, because then where would I put that middle term? That's why I'm going to have to use the quadratic formula. My other two methods don't work. Since it's in that form, I can say A is the coefficient of x squared, which is 2. B is the coefficient of x, which is negative 4. C is the constant, so it's 1. And then it's just plug these numbers into this formula, simplify as much as possible. Zoom out just a tiny bit so I can see the formula and my A, B, and C at the same time. And start substituting. X equals, this negative B means the opposite of B. If B is negative 4, then the first number in that formula is going to be positive 4. Plus or minus the square root of B squared. What's wrong with the way I wrote that? Yeah, and I'm going to make that mistake every time to try to get you to catch it. If you want to square negative 4, you have to have negative 4 in parentheses. B squared minus 4 times A times C. All divided by 2 times A. Simplifying what's under the radical. Negative 4 squared is 16. So this is 16 minus 8. That's just 8. And then square root of 8, I need to simplify that like I did yesterday. Yesterday I looked for the largest factor of 8 that was a perfect square. What's the largest factor of 8 that's a perfect square? 4. So I could write that 8 as 4 times 2. And then I could say the square root of that 4 is 2. And write it out in front of the radical. Now, any steps that you can do in your head and consistently get the right answer, that's okay. If you can say square root of 8 is 2 square root of 2 without writing this step down, yay, that makes me happy. But in my notes, I'm going to try to give you every step you might need. All right, finally, to get this answer in the way that it's written, or that MyLab wants you to enter it on the computer in your homework, split that into 2 fractions. 4 over 4 plus 2 square root of 2 over 4. And just reduce each fraction. 4 over 4 is 1. And 2 square root of 2 over 4 is just square root of 2 over 2. You say 2 goes into that 4 2 times. I lost my minus where I'm saying plus or minus. I needed to keep that plus or minus. Now, I'm not sure about this, but I think the homework, MyLab says, write your answer, answers, plural, separated by a comma. That's just asking you to write 1 plus this as one of your answers, comma, 1 minus that as another one of your answers. I don't have room to write it there, but that's what write your answers separated by a comma means. All right, B part. Let's do the same thing. A is 1, B is -2, C is 1. Yeah, I do mean 4. Yeah, A is 4, B is -2, C is 1. And then it's just plug and chug. X equals the opposite of B would be +2 plus or minus the square root of B in parentheses squared minus 4 times A times C, all divided by 2 times A. Under the radical, that would clean up to be 4 minus 16. What's 4 minus 16? -12. All of a sudden, what do I know about this answer? It has a square root of -12 in it. It's not a real number. And so far, that's all we can say about it. It's not a real number. I don't know what it is. That is actually what lesson 10 is. We're going to talk about this application real quick, and then lesson 10 tells us how to deal with square root of a negative, other than just writing not a real number. We can write what it is. All right, before we do that, let's look at this word problem real quickly. And I plug the numbers into the quadratic formula. I have this thing almost done for you because I knew we wouldn't have time to write it out in class. It says an object propelled vertically upward with an initial velocity of 20 meters per second. I think I left out the verb there. An object is propelled vertically upward. The distance S Gotta know what my variables stand for, and it's telling me S is a distance from the ground. And T is a number of seconds. So they've given me a formula for calculating, you give me a time, I'll tell you how far above ground the object is at that time. If you say, how high will it be in 2 seconds? I'll put 2 in place of T. If you say, how high will it be in 1.5 seconds? I'll put 1.5 in place of T. But that's not actually what this is asking me. This is asking me when. Does when mean I'm looking for a distance or a time? That's a time. When means find T. When the object is 15 meters above the ground. What's that 15? That's my distance. Find T when S equals 15. That means put 15 in the place of S in this equation. 15 equals negative 4.9 T squared plus 20T. Now, I don't think I'm going to be able to factor it with that negative 4.9 in it, but I'm going to need it in standard form. To get it in standard form, I could subtract 15 from both sides. I chose to add the 4.9 T squared and subtract the 20 from both sides. That's what I have in standard form. And then I just extracted those numbers, plugged them into the quadratic formula, have one just like this in the homework. And under the radical, that all simplified to square root of 106. We're going to get decimal approximations. We're going to punch this on the calculator in just a minute. But even without a calculator, what's square root of 106 close to? What whole number is that close to? It's just a tiny bit over 10. Square root of 100 would be 10. This may be 10.2-ish. And this is darn close to 10 as well. So I'm just trying to guess what my answers will be close to. What's 20 plus 10? 30, and 30 divided by 10? One of my answers is going to be close to 3. The other answer, 20 minus 10, is 10. 10 divided by 10 is 1. So I'm expecting answers close to 1 and close to 3. Now, if the directions on the test say round to the nearest tenth, though, I don't think I can do that in my head. I think I'm going to have to punch 20 plus square root of 106 divided by 9.8. That should give me something close to 3. And then 20 minus square root of 106 over 9.8. That's going to give me the one that's close to 1 second. Has anyone punched this already and gotten the number close to 3? Chloe? Chloe, yes.
3 point.
I'm just checking my names. 3.09. Okay, let's say it rounds to the nearest 100. So 3.09 seconds is one of our answers. And what's the other one close to? 0.99. That's darn close to 1. Now, how does this problem have 2 answers? How are we getting 2 times that the ball or the object is 15 meters above the ground? How can there be 2 times that it's going to be 15 meters above the ground? Can you draw in the air the path? If you toss the ball up in the air, draw in the air the path that the ball would take. Now. It would go up, 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 and then it would come down. We popped it on balls before. So how are there two answers to that question?
True twice.
No,
It's gonna happen.
it's is 15 meters high on the way up, and then it's 15 meters on the on the way back down. So this ball, this projectile, whatever it is going up, 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 and it's coming back down. It's gonna hit 15 meters at about 1 second and at about 3 seconds. One's on the way up, one's on the way down. And the B part says, when will it strike the ground? Well, once again, when means find T. But if you want me to find T, you have to give me a value for S. In the A part, they gave us S is 15 when the ball is 15 meters above the ground. What is the height of the ball when it hits the ground? 0. Hits the ground means S is 0. So if you put 0 in place of S in this equation, you'll have 0 equals negative 4.9 t squared plus 20 t. I could use the quadratic formula on that as well. If I did use the quadratic formula, what would C be? The constant on the end is 0. A would be negative 4.9, B would be 20, C would be 0. That's not the easiest way to solve this. It's much easier to just factor out a t. And then set each factor equal to 0. What's that going to be darn close to? What? 20 divided by almost 5. That's going to be darn close to 4. Somebody, since we've rounded the others to 2 decimal places, would somebody give me that to 2 decimal places? Piece of piece. 4.08. You could have figured that out approximately just by saying if the ball is 15 meters high at 1 second and 3 seconds, what's it going to be, or how many seconds is exactly halfway between those two? 2 seconds. And if the ball spins 2 seconds going up, how long is it going to spin coming down? 2 seconds. And so a total of 4 seconds. All right, the C part, once again, I've typed it all in because I knew we wouldn't have time. But it says, when will the object will the object reach a height of 100 meters? I put 100 in place of S and then got it in standard form and plugged all those numbers into the quadratic formula. But what can I say right here? That's not a real number. Does that answer the question I was asked? If somebody says, will the object get 100 meters high? Am I going to answer that question with, it's not a real number? I'm going to answer that question with no. And no, the object not reach 100 meters. Because that's not a real number. And for 99%, probably 99.9% of people on the planet, all we really care about is real numbers. I've never needed an imaginary number at Walmart. Never needed imaginary numbers any time in my life. But there is a whole field of mathematics that involves numbers that aren't real numbers, and there are people who use them daily on their jobs. Folks who use numbers who aren't real numbers, computer scientists, electrical engineers, nuclear submariners. That's 3 I know of. That's the only 3, but you could Google and find some more. Those folks definitely care about not only the real number solutions, but also the not real number solutions. So let's see what we can do on lesson 10. Let's talk about numbers that aren't real numbers. That last problem that we just did, the question, when will the object reach a height of 100 meters? When we plugged and chugged, which we just finished, and got right here, we knew that the answer was no, it's not going to reach 100 meters because this is not a real number. But many scientific applications in engineering, physics, software development, and so on require solutions which are not real numbers. Of particular interest is the imaginary unit I. From now on, instead of writing not a real number, we're going to write an answer with an I in it. Leonhard Euler, sometime in the 1700s, was the dude, because women weren't allowed to do math back then. Leonhard Euler was the dude who says, I'm going to invent notation for the solution to this equation. This equation has stumped mathematicians for centuries. I'm going to invent something that we can use to solve this equation. Now, at first, maybe he wasn't stumped. He just subtracted 1 from both sides. And then he took the square root of both sides. And bells and whistles went off in his ancient white head. And what did he have to think? Take the square root of both sides. Don't forget the plus or minus square root of -1. And up until this point in history, everyone just threw up their hands and said, well, that ain't nothing. I can't do nothing with that, if they had really bad grammar. Leonhard Euler was the guy that said, from now on, whenever I encounter square root of -1, I'm just going to use an I in its place. And that opened up a whole new field of mathematics that allowed people to do things they'd never been able to do before, that allowed engineering, physics, and software developers to start solving problems they had never been able to solve before. So from now on, I is called the imaginary unit. It's the number that if you square it, you get -1. I squared is -1. And I wish I'd had one more sentence in there. I'm just going to say, and I is the square root of -1. Now on, whenever we see square root of -1, plop an I in it and keep going. For example, this A part. Square root of -49. Yesterday, I would have just said not a real number. But today I can say, you know what? That is the square root of 49 times the square root of -1. Is that a true statement? Yeah? And what can I put in place of square root of 49? If I'm using this symbol, then I only mean the principal square root. I don't have the plus or minus unless I'm taking the square root of both sides of an equation. So in place of square root of 49, I'd just put 7. And what can I put in place of square root of -1? I. From now on, instead of not a real number, we're going to say square root of -49 is 7i. That's not a real number, it's an imaginary number, but now I have some good, easy notation for it. Square root of -125, like I did yesterday, I'm going to factor that into something that is a perfect square times something that's not. -125 is -25 times 5. And I know square root of -25 is not a real number, but what can I put in its place? 5i. Yep, 5i. And just leave the other 5 under the radical, just like I would have yesterday. Now, you can also write that as 5 square root of 5 with the I after it. And that actually makes more sense because you could get a decimal approximation of 5 square root of 5. That would be 2 point something. So 5 square root of 5 would be probably 11 point something, maybe 12 point something. This actually makes more sense. The reason I don't write it this way in my notes is folks make their radical too long, and then it looks like the I is still under the radical, and the whole universe would explode if that happened. So I write it like this just to make it very clear the I is not under the radical. Now we know numbers that are real numbers, and we know numbers that are imaginary numbers. If we put the real numbers and the imaginary numbers together, we come up with the biggest set of numbers there is. The biggest set of numbers there is complex numbers. Complex numbers have a real part and an imaginary part. They're written in the form a plus bi, and the a is called the real part of the number, and the bi is the imaginary part of the number. Example 2 says, write this in the form of a complex number. It has a real part. The real part's 4. The imaginary part is the square root of -36. What could I put in place of square root of -36? 6i. So that's 4 minus 6i. It's in the form, a is 4, b is -6. Real part's 4, imaginary part's -6i. The b part, real part is -5, but -32 is not or 32 is not a perfect square. So I'm going to have to factor it into -16 times 2. And then what can I put in the place of square root of -16? For I. Or I square root of 2.
So why would there not be I?
Let me write or here, -5 plus 4 square root of 2i. Just like I said here, this is actually a better form because you could get a decimal approximation of this. I just write it like that to make it clear I is not under the radical. In the homework, I think you're going to have to type it in like this, because if the directions say write in the form a plus bi, then your b is this 4 square root of 2. They want that before the I. Once we had this new notation that allowed us to write imaginary numbers in terms of I, or any number in the whole wide world in the form of a complex number, all of a sudden we could do things we'd never been able to do before. We can add complex numbers, we can subtract complex numbers, we can multiply complex numbers. For example, in Algebra 1, in about the 8th grade, if you hadn't told me anything, I don't know, if you hadn't told me that I was something special, I would have just treated it like an X. I would have said, that's 6 minus 9i minus 3 minus 6i, because I know I have to distribute that -1. And when I combine like terms, that's 3 minus 15i. So I could have gotten that answer without even knowing I was anything special. And the same thing here. I could say, what could I put in place of square root of -36? 6i. I don't need that parenthesis anymore. That first complex number is 5 plus 6i. The second one is 2 minus what? 7i. So when you combine like terms, you get 7 minus I.
Can you go back over to A?
Yes, ma'am. Need to finish copying it down, or did you have a question?
I just had to finish.
Okay. All right, so we can add and subtract complex numbers without knowing there's anything special about I. But when we multiply, if we multiply an I times an I, what is I times I? I squared, but I squared is -1. I squared is -1. So in this A part, without even knowing I is anything special, I could go, I'm going to distribute a 9i. 9i times 4 is 36i. 9i times 5i is 45i squared. But this is your third hypnosis of the day. Whenever I see an I squared, I'm going to put in what? -1. 36i plus 45 times -1. And then if I want my answer in the form A plus BI, which the direction said, I'm going to write my real part before my imaginary part. We're not going to do this B part because I really got to get to something on the back of the page. But if I just look at that and think it's a binomial times a binomial, how do I multiply a binomial times a binomial? The acronym that helps me. That's FOIL. I'm going to FOIL that out. And when I get an I squared on the end, what am I going to put in its place? -1. All right, I think you can handle that. Notice I already planned to put a big old X through the whole top of this page. We can live without it. We have to live without it. You barely shows up, but you don't need any of that for the test, and we don't have time to talk about it. So we're going to skip down to this last thing, and yay, we'll be all caught up. Quadratic equations again. And let's play like I don't know anything special is happening. I'm looking at this example 9, A, B, and C. All three parts are quadratic equations. So when I look at A, I go, will that factor? Nah, won't factor. My second method is square root method. Could I get it to just be x squared on one side and a constant on the other? What would I have to do in order to have it in that form? Subtract 8, so I'd have x squared equals -8. And then I'd take the square root of both sides, and bells and whistles would go off to remind me what? Don't forget the plus or minus square root of -8. And up until this minute, I would have just said not a real number. But now I can write that as a complex number. I can say square root of -8 is -4 times 2. And what can I put in the place of square root of -4? What's square root of -4? Thank you. Plus or minus 2i square root of 2. Notice the 2i is just in front of the radical. It didn't hop out in front of this plus or minus. And if the directions on the test say, or if directions in the homework say, write your answers separated by a comma and in the form a plus bi, you're going to need to write the two solutions as +2 square root of 2 times I and -2 square root of 2 times I. And I'm making it very clear that I is not under the radical. All right, we only have time for one more, so we're going to do this one. It's already in the form of a quadratic equation. There are no factors of 10 that have a sum of 4. That tells me it won't factor. I'm going to use the quadratic formula where A is 2, B is 4, and C is 5. X equals the opposite of B. Make sure you get this memorized correctly. The opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. -4 plus or minus the square root of, all of a sudden I have 16 minus 40. 16 minus 40 is -24. What do I know about this answer all of a sudden? It's not a real number, but I can write it in terms of I, and that's what I'm asked to do. I'm going to write that square root of -24 as -4 times 6. And then in the place of the square root of -4, I'm going to put what? 2i square root of 6. And then split it into 2 fractions. I wrote that 2i square root of 6 as 2 square root of 6i. I just split it into 2 fractions, and it would reduce to -1 plus or minus square root of 6 over 4 I. Because this 2 go into that 4 2 times. Oh, so it's a 2 in the denominator. I love when I mess up last thing. All right, you've got a lot to do this weekend because we didn't finish assignment 9 last night. You got to finish assignment 9 now, and you can do assignment 10. It is a little over a week until the test. Today's the 2nd, and the test is it's a little over 2 weeks to the test. But I already have this in momentum for you, and I think some of you will be serious, take it seriously this time. Maybe they didn't take it seriously last time. Since we finished through lesson 10, you could do the first 21 problems on the practice test if you wanted to start working on it this weekend. 1 through 21. All right, see ya. Yes, ma'am.
I probably won't be here Monday because
Okay.
I'm having a procedure and I'll be driving for
What would that be?
the 7th.
Radical equations and equations in quadratic form. I just realized I need to stop this video. It's still getting me.